Hi everyone, this is Mike. I'm one of the admins from the Moon Landing Hoax Facebook group. I had done a live stream the other day that people seem to have liked, and I figured I would try a second one today. This live stream is going to be in regards to the Apollo photography and how we prove that the non-parallel shadows that we see are evidence that the moon landings were indeed a hoax. Now you can see right before me here, I'm showing you a photograph from Apollo 17. I have it labeled as AS17 136 20744. This is the same photograph that I referenced in my prior live stream, and I'm referencing it again. This time I'm sharing screens with you so that you can see the photograph for yourself. Now, one thing you'll notice, of course, in the photograph is that the camera is pointed downward toward the ground, and I have a reference photo to the right, or image I should say, taken by myself with the digital camera, showing a comparison between the two photos. Now, you notice here that you can see the astronaut shadow going 12 o'clock straight forward. You can see a rock in the upper right quadrant with a shadow going to the left. Also, right next to the astronaut, I've zoomed in here so you can see, we have also the small rocks on the ground also going to the left. Now, under normal sunlight, okay, and recall all of the Apollo missions were photographed in sunlight. You can look up the official NASA record, and it says that no artificial light was taken to the moon, meaning that the only light source they had was the sun. Okay? Now, the sun is 109 times larger than the Earth. It's 90 plus million miles away from the Earth. Now, the moon is 240,000 miles from the Earth. So for our purposes here in these comparisons, the Earth and the moon are about the same distance to the sun, okay? So the sun being 90 million plus miles away, it doesn't make a difference that the moon is 240,000 miles from Earth. The effects we're going to see on the ground should be the same. Now, why is that? Look to the right here, and you see parallel shadows, okay? The shadows go all facing about 12 o'clock, as you can see, okay? The camera is pointed toward the ground. They are not going perpendicular like you see in the left Apollo photo, okay? The reason why shadows go parallel when the light is cast by the sun is because, number one, the sun is many, many, many times larger than the Earth, and of course the moon as well, okay? It's much bigger. And number two, the sun, the sun is many, many millions of miles away, 90 million miles away, okay? When you have a light source that is close up, depending on the angle at which the object is relative to that light source, the shadows can be cast in different angles, okay? Here, you see the shadows are all facing the same direction, approximately 12 o'clock, okay? There can be a little bit of discrepancy, but you're not going to see a 90-degree difference like you see where this rock is going exactly to the left, and the astronaut shadow is going straight forward. All right, so this is a discrepancy that can only be explained really by studio lighting. Okay, I can show you another example from the Apollo 17 record. Let's take a look at this one right here. This is Apollo photo AS17 138 21150. Okay, look at these shadows here when we zoom in. Okay, where the camera's going straight to the ground, showing this the the shadow of the astronaut, and you can see one shadow is pointing to the right, and then the other shadow, of course, is pointing to the left. If this were actually lit by the sun, the shadows would all go straight ahead. You would not see the effect that you're seeing in this particular photo, okay? AS17 138 21150. I'll show you how you can look all these photos up, by the way, at the end, okay? Now let's take a look here, and I've got cataloged on my website, stratagemsoftheright.blogspot.com. I have listed a bunch of photographic memes I've put together of the Apollo record, and you can see them all yourself. And I have plenty of different examples that I go through here, okay? Bear with me for one moment. So let's keep going down to a couple that I could show you for a reference comparison. In fact, let's go to Apollo 16, okay? I'm going to show you some right here. We'll keep going down. Let's look at another one. This is photo AS1611318313, okay? And you can see here when we zoom in on the astronaut shadow, we have again, on opposite sides of the photograph, one going to the right here, another one going to the left. And the shadows not only are perpendicular, they are directly pointing at each other, okay? Now, if you look to this photo I've taken here, all the light converges toward the horizon, okay? And for something I'm about to get into in just a moment called perspective, that's one of the explanations our trolls will give to show how, you know, this of course could be natural and it has nothing to do with studio lighting, okay? Here, as you can see, we've got some lighting coming from the direction to the right, some to the left. When we zoom in on Apollo 16 photo AS16 113 we do see an example of the shadows pointing directly toward each other, okay? And in here, as you can see, all the rocks I see on this plain ground, they're all going and converging toward a point, but they are not pointing directly toward each other, okay? Now, what our trolls like to do is they like to reference my right photo and say, well, yeah, the shadows do not necessarily go directly parallel. They point toward each other, right? Well, that's called perspective. Now, I'm showing up a photograph here, some train tracks to show as an example. Show lines converging toward a horizon, as you can see here. But notice how that is completely different, okay, from the picture we see here, Apollo AS16 113 we don't have shadows converging toward a horizon like you can kind of see on my right photo here. You have clearly shadows on two opposite ends of a plane, okay, completely straight, no curves in the plane, as you can see here. You could use it as an excuse. We have some shadows going to the right and some to the left, okay? And we can see here, I'm referencing back to photo AS17 136207444. Again, the camera's pointed to the ground. You don't see shadows converging to a point. You see one shadow right here going directly to the left and another one going straight ahead at 12 o'clock for the astronaut. This can only occur with studio lighting, okay? This cannot occur from natural sunlight. And the Apollo photographic record is filled with these types of examples. Now, where can you go if you want to get these photos and see more examples for yourself? And I encourage you very strongly to do that. Let's go through how we can do it, okay? The easiest way is to go to flickr.com/photos/Project Apollo archive/albums. If you go there to that website in Google, you'll get the website right here, and you can see here each individual Apollo mission, and you can click on each individual Apollo mission by their number. So for example, we have Apollo 7, Apollo 8, Apollo 9, and we can keep going through. If we wanted to see the photos I was looking at, we go all the way down to Apollo 17. Okay, and what photo was I looking at? 136-20744. So how do we find that photo? Well, we go to the magazine, which is magazine 136. Okay, so we go all the way down here and we find magazine 136 and we click it. Boom, right there it is. And then we get the photo number. As you can see here in the upper left, it's 20744. So you can scroll down through this and find a photo number 20744. As I hover the finger icon over each photo, you can kind of see each photo number. So that's how they're labeled. AS17 is Apollo 17, 136 is the magazine, and then after that you have the photo number 20706. Okay. Now you can say, well, Flickr, maybe they're putting up doctored photos. It's not an official NASA source, so where do I go? Well, you can go to the Apollo Lunar Surface Journal, which is on the .gov, hq.nasa.gov website. You can see it here in the search bar I have up here at the top. You go to that website and you can download all of the photos by their mission number. So Apollo 11, 12, 13, 14, 15, 16, and 17 are all on there. You just click enter the journal, and I'll show you kind of how to find these photos for yourself if you want to look at them as a researcher and find more anomalies and examples that I've just talked about, okay? But before I do that, I want to show you something pretty funny on here. You can see I'm scrolling. You can see here that the Apollo Lunar Surface Journal is, in Neil Armstrong words, a quote, living document and is constantly being modified and updated. Please don't hesitate to let us know about errors. We want to get it right, but sometimes that can take a while. We would like to thank everyone for their help and patience. You may email the editors concerning typos, factual errors, or general comments at apollolunarsurfacejournal@gmail.com. Well, isn't that interesting, right? What could we plebs possibly get right after over 50 years where we need to send this to these discoveries we're finding and errors to a Gmail account for somebody to manage this page and correct them for us? I just thought that was interesting. You guys would get a kick out of it. But how it works is this is on the NASA website, but it is edited by private parties. You can see it's by Ken Glover here and by founder Eric M. Jones. So those people take care of the journal, and it is hosted on NASA's website. So you click the journal, you go through it, you click your mission. For example, you can go to Apollo 17 here, and you can go, and they've got everything in chronological order if you want to research it. They have video clips. However, you'll have to download Real Player to see them. So if you're interested, you can, of course, go to the Apollo Lunar Surface Journal webpage, and you can download the photos yourself and take a look. So I thought you guys might get a kick out of that, find this interesting. This is my second live stream attempt. I'll do a third one if you like this. So drop a like and a comment below if you find this interesting. If you don't find these interesting, I will go ahead and stop them going forward. Hope you guys are having a good day. Take care, and we'll see you again on the next live stream. Bye-bye now.